In 2014, the tip of Cerro Aramazones in the heart of Chile's Atacama Desert was removed in quite a dramatic fashion. The result was a flat plateau, representing the very first stage in ESO's most ambitious project yet, constructing the European Extremely Large Telescope, or E-ELT for short. Now, ESO has awarded the biggest contract in ground-based astronomy to build the E-ELT dome and telescope structure. So it's a good time to take a look at what the E-ELT will be. This is the Esocast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. Not far from ESO's Paranal Observatory, Cerro Aramazones will be home to the E-ELT, one of the next generation of enormous telescopes. A main mirror 39 meters across and a protective dome almost 80 meters high will make this one of the biggest astronomical projects ever undertaken. Truly an extremely large telescope. The E-ELT is, like all big astronomical telescopes, a reflecting telescope. Mirrors are key to its operation, and there are 5 of them in total. By bouncing the light from one mirror to another, it's possible to make the telescope relatively compact. Without this series of mirrors to fold the light beam, the telescope would be even bigger. The mirrors can also be used to make adjustments that result in the best images possible. The main mirror is segmented and is made up of 798 individual elements, which together add up to a reflecting surface 39 meters across. The faint light from distant objects is reflected from the main mirror via the 4 other mirrors, eventually reaching the focus of the telescope, where sophisticated scientific instruments will be placed. The M4 mirror is particularly special. It's a very thin, flexible mirror that sits at the heart of the E-ELT's adaptive optics capability. Adaptive optics systems flex and bend the mirror by tiny amounts and with great precision to compensate for the blurring effect of the Earth's atmosphere. This will allow the E-ELT to produce images of celestial objects around 15 times sharper than the Hubble Space Telescope. The E-ELT will be equipped with a suite of world-class scientific instruments, as befits the most powerful telescope in the world. Work is already underway to design these devices, which will help to exploit the enormous observational power of the telescope. But in the midst of all this magnificent engineering, let's not forget that this is all about the science. As the biggest and most sophisticated telescope ever built, the E-ELT will take us into a new era of observational astronomy. Its gigantic primary mirror will do 2 things that set the E-ELT apart from the current generation of large telescopes. First, it will collect about 15 times more light than any other optical telescope in operation today, enabling scientists to observe much fainter objects than they can now. And second, when coupled with the adaptive optics system, it will produce images that are much sharper and more detailed than currently available. This will enable astronomers to study planets around other stars in unprecedented detail. We will learn about how they form and the conditions on their surfaces. We may even find a planet similar to the Earth, and perhaps hope to find evidence for some form of life on another world. And the distant universe will be revealed in ways never before possible. The E-ELT will answer important questions about how the universe as we see it came into being and what the future will hold. It will enable us to study the evolution of galaxies from the earliest times, and will tell us more about some of the nature's most violent events, when black holes at the centers of galaxies accrete material and become active galactic nuclei. ESO has a long and proud history of pushing the boundaries of astronomy, both the engineering and the science. The E-ELT is the next step in ESO's remarkable quest, indeed humanity's remarkable quest, to unravel the mysteries of the universe. It's a huge step, but it will certainly not be the last.